Section 3.7, Rational Functions. In this section, we'll use arrow notation, we'll solve applied problems involving rational functions, find the domains of rational functions, identify vertical and horizontal asymptotes, and finally graph rational functions. So here's our first graph of a rational function. This is a graph of the function 1 over x. And one thing to notice is the behavior of the function in terms of long term. So let's just take a look at arrow notation. When we write something like as x approaches infinity, and we've seen arrow notation before, but now we'll just apply it to rational functions. What this means is as x gets larger and larger. And usually what we write is as x approaches infinity, we want to know what the y values are doing. In other words, what is f of x doing? Is f of x approaching a certain number? Well, if we look at this graph, as x gets larger and larger, it looks like the y variable, the y values are getting smaller and smaller, but they aren't going negative. It looks like they're just getting closer and closer to 0. So we would write as x approaches infinity, f of x is approaching 0. Let's go in the other direction. As x approaches negative infinity, meaning as x gets smaller and smaller, as it keeps going more and more in the negative direction, and we can follow this along. As we start going more and more in the negative direction, we can see that the function, again, is getting closer and closer to the x-axis. It's getting closer and closer to 0. But we have no indication that it's going to cross the axis and become positive. So as x approaches negative infinity, f of x also approaches 0. But notice that the function has a special behavior also as we approach 0, but it has a different behavior depending on if we're approaching a 0 from the left side or if we're approaching 0 from the right side. So when we write this, x arrow 0 plus, what this means is as we approach 0 along the x-axis from the right. So let's literally take our pencils and we will just trace this graph, and we're going to start on the right side and we're going to get closer and closer to 0. So 4, 3, 2, 1, getting closer and closer to 0. What do we see the function doing? We see the function getting higher and higher and higher. As a matter of fact, the arrow indicates it's just going to keep on going up without bound. So what that tells us is that as we approach 0 from the right side, f of x just keeps getting bigger and bigger and bigger. In other words, f of x is approaching infinity. But as x approaches 0 from the left-hand side, as we come from the other direction, we can see that something different happens. We're not getting bigger and bigger, we're getting smaller and smaller and smaller. In other words, as we approach as x approaches 0 from the left-hand side, f of x is approaching negative infinity. And we're going to talk a little bit more about what these boundary lines as we approach, for example, as we approach 0, we see that the function gets very close but doesn't touch. As the function, as we look at the y values, something interesting is going on at the x-axis as well. We're going to talk about what these lines are called in a little bit. Let's take a look at the function f of x is equal to 1 over x squared. And we're going to do the same arrow notation again. So as x approaches infinity, again, remember what that means as we're going along the x-axis and getting larger and larger and larger, we can see that the f of x values are approaching the x-axis. In other words, f of x is approaching 0. Similarly, as x approaches negative infinity, again, along the x-axis, we're going to start going and getting less and less negative, more negative. What are the y values doing? And again, they're doing the same thing that they're doing on the other side. The y values are approaching 0. Notice as x approaches 0 from the right, and as x approaches 0 from the left, let's change that to left, the same thing is happening on either side. As we approach 0 from the left, the function's getting larger and larger. As we approach 0 from the right, the function's getting larger and larger. So for f of x is equal to 1 over x squared, whether we approach 0 from the right or whether we approach 0 from the left, the function values just keep getting larger and larger. In other words, the function values are approaching infinity. So these lines are given special names, and they're called asymptotes. So a vertical asymptote of a graph is the vertical line. Now remember, vertical lines have the equation x equals, so x equals some constant, where b is just some constant, where the graph tends towards positive or negative infinity as the inputs get closer and closer to b, or in other words, as x approaches b. Written in symbols, that's as x approaches b. So let's take a look here. We would say that the vertical asymptote of the line f of x, of the function f of x is equal to 1 over x squared is the line x is equal to 0, because the graph tends towards positive or negative infinity as we get closer and closer to 0. So as the x values get closer and closer to 0, the function approaches infinity. That makes this line x equals 0, in other words, the x-axis, a vertical asymptote. Notice in our first example, the y-axis. The y-axis, let me change that over here so your notes are not confusing. In our first example, the y-axis is also a vertical asymptote because as the function approaches 0, the y-axis, we are going to infinity or negative infinity. So a vertical asymptote of a graph is the vertical line x equals b, in this case 0, where the graph tends towards positive or negative infinity as the inputs get closer and closer to b. So in other words, as x approaches b, f of x approaches infinity, or as x approaches b, f of x approaches negative infinity. So let's take a look at this example here. So for the vertical asymptote of this function, notice that as we approach the line x is equal to 2, as we approach line x equals 2, let's do it from the left-hand side. As we get closer and closer to 2, notice that the function is going more and more negative. So as x approaches 2 from the left, the function is approaching negative infinity. And as we approach from the right, the function is approaching positive infinity. That makes the line x equals 2 a vertical asymptote. So why don't you try this example? Looking at this graph, see if you can identify the equations of its vertical asymptotes.